Hello everyone, in today's video we are going to make the smart power saver system. In the smart power system, we can control the LED smartly by using the LDR that will detect the light in the room and accordingly will turn on or off the LED. Also, we are able to control the LED manually by using an IR remote. So here the system will work in two ways. One is the manual mode by turning on and off the LED using an IR remote, or automatic in which we will use an LDR that will according to the light in the room, it will turn the LED on or off. So let us see the components required. We need an Arduino Uno board, an LED, one LDR, one 1 kilo ohm resistor, a TSOP IR receiver, IR remote, connecting wires and some breadboard. So let us do the connections now. So first of all, we will place the LDR on the breadboard. Place the LDR in such a way that one of its terminal is connected to the negative rail of the breadboard. And then take one more resistor, connect its one terminal to the LDR and other terminal to the positive rail of the breadboard, and take a connecting wire and connect this terminal of the LDR to pin A0 of the Arduino. Then you take a LED, place it a little bit far from the LDR, connect its cathode to the negative rail and connect its anode to pin 6 of the Arduino. Now after that we will place the IR receiver on the breadboard. So it's 3 pin. This is the output pin, the middle is the ground, and on the left side we have the VCC pin. So first we will connect the ground pin to the negative line. Then the output pin to pin 11 of the Arduino. And the positive to the positive rail of the breadboard. Then we will take 2 more wires, connect the positive rail to the 5V pin of the Arduino and the negative rail to the ground pin of the Arduino. So our connection is done. Now we will upload the code. Now we will discuss the code of the power saver project. So here first we have included the IR remote library. This will enable the Arduino to receive and decode the IR signals from a remote control. Then we have defined the pins of the IR remote, the LDR pin and the LED pin. Now we have defined the codes for the IR buttons. So here there are 3 buttons. Button auto will enable the automatic mode, button on will manually turn the LED on, button off will manually turn the LED off. So here this codes can be different for different remote. So you have to first upload the code, check the codes for each remote button in the serial monitor and do the changes accordingly. Then we have a boolean variable auto mode which is used to control the system's behavior. If it is true, then the system is in automatic mode, and if it is false, then the system is in manual mode. And one more variable to store the values from the analog LDR pin. Now inside the watch setup we have declared the LED pin as output and made the LED low, means we have turned it off initially. We have initialized the serial communication with the baud rate of 9600. We have initialized the IR receiver. So this will activate the IR receiver on pin 11, and we have printed this message in the serial monitor. Now inside the void loop, first we will check whether the IR receiver is receiving any signal or not. Then if any signal is received, then it is extracted from the IR data and stored in the variable named as value, and then we will print the extracted command in hexadecimal format in the serial monitor. Then if the auto button is pressed, then the auto mode will be true, and which will enable the automatic control system, and it will print auto mode enable. Else if the button on is pressed, then the auto mode will be turned off and the LED will turn on. And if the button off is pressed, then again the auto mode will turn off and the LED will turn off. And then we write here IR receiver .resume. This will prepare the IR receiver to detect the next signal. Now here again we are giving the condition that if the system is in auto mode, then we will first store the value of the LDR sensor in the variable and then print the variable in the serial monitor. This is basically done so that we can check the sensitivity of the sensor. Different LDR sensor will give different values according to the intensity of light. So we have to adjust this by checking in the serial monitor, and by standard, in my case, when it is greater than 900, means light is not falling on it. As soon as it will detect light, the value will reduce below to 900. So I am giving here, if LDR value is greater than 900, that means no light is falling on the LDR, the room is dark, my LED will turn on. Else if there is enough light, then my LED will turn off. And here I have given a delay of 100 to avoid any fluctuation. So this is all about the code. Once your code is done, you click on Tools, select the board as Arduino Uno, select the required COM port, and then click on Upload. Your code will be uploaded to your Arduino board. Now we will show you the output. So the LED is turned off. So I will use the manual mode to turn it on. So in my remote, this is the manual on, manual off, and the blue is for the auto mode. So I will use now my LED is in manual mode. So this is for turning it on. You can see the LED is turned on, and if I press this button, the LED turns off. Now I am giving the enable auto mode. So the LED is turned on since the LDR has no light falling on it. As soon as I will provide light, the LED will turn off. You see, LED has turned off. And as I remove the light from the LDR, it turns on. And then if I put it in manual mode turn on, then even if I put light on the LDR, it's not turning on. It's not turning off. It's turning off only by manual off button.